or live. So yeah, let others know as usual that this meeting is going to be recorded and it's going to be available on YouTube. We also say hi to Steve. Thanks for being with us today. We don't have that many people today. I don't know, maybe they're sleeping through. I don't know. 11:30, I think, is a good time for, waking up, doing some stuff. Anyway, I made sure I sent you guys the announcement and the information last night, so hopefully you could be here. So let's begin. I'm going to go over some of the concepts of sections 9.4 and 9.5, all those regarding the basic trigonometric functions or ratios. Okay, I'm going to go briefly on the definition, and then I'm going to solve a couple of exercises, and yeah, that's pretty much what we're going to do today. As usual, if you have a question, make sure you type it and enter it on the chat box. And yeah, I think that we will have enough time for to go over that question if necessary. I scheduled and planned this lesson to be probably 1 hour. I mean, I made it to be 1 hour. Maybe it's going to be a little bit less than that, but because of the different topics that we're going to deal with today, so it probably is going to be longer than the 30 usual minutes that we're asked to have in our in this kind of lessons, video lessons. Okay, so okay, let's begin right away. And okay, relationships you find in right triangles. And okay, give me a second, need more light here. Okay, so the thing is, if we take a look at the legs, we know that C is the hypotenuse. It means that it's the longest segment of this triangle. We know that a right triangle has a right angle in it. And also we know that these angles, and let me just finish with labeling here. Probably I think that this is the best way to go over this. So A, this should be B, and this should be C. So the angles in A and B are both acute angles. It means they're less than 90, but when added, and they are supplementary angles, which means they to take into account before we move on is let's have the common vocabulary here, so we're all on the same page. So if we focus on angle A, so things to take into account is that A is what we call the opposite segment to angle A, and B, the adjacent segment to angle A. C is the hypotenuse. If I was standing here on B, then now to switch. Now for B, if you're standing here, you can see that B is your opposite, and segment A is going to be your adjacent segment. Okay, this is important to clarify, and in order for us to determine the following ratios or definitions we are going to go over today. Okay, that said, now let's begin. We are going to now define these three basic trigonometric functions. Okay, so let's begin. 9.4 begins with tangent, and then 9.5 gives you, or goes over sine and cosine. I don't like it that way, but anyway, I'm going to use the book as a reference. So anyway, so if to do this, let's stand on angle A. Okay, if you're standing on angle A, we're going to define three new, mathematical ratios here. So the first thing is that if I do this ratio with A, the opposite segment divided by the adjacent segment, yeah, we're going to do this division. It means we're going to do A over B. Okay, this ratio of A over B is what we call, hopefully you already know because you have been reading, right? Is what we call the tangent of A. Okay, that's it. Simple, right? Okay. Also, if we're standing on A, we need to have a point of reference. So we're standing here in A. Okay. Also, if we do this, now we're going to do the opposite segment divided by the hypotenuse. All right. It means I do A divided by C. All right. That's what we call the sine of A. All right. And finally, and I think I'm going to have to do it here. If I do, what are we missing? I have to do this divided by this. If we do adjacent divided by the hypotenuse, that's, in this case, B divided by C, is what we call the cosine of A. All right. That is the definition. We have sine, cosine, and tangent. What is the definition of tangent? You're standing on this angle, and the tangent of an angle is the ratio of its opposite segment by and its adjacent segment. Okay, opposite over adjacent. The definition of sine, it's sine of A is the opposite segment divided by the hypotenuse. Okay, it means A over C. And here, definition of cosine, it's the ratio of the adjacent segment divided by the hypotenuse, or in this case, B over C. That's the story. If you want to remember that, there's a mnemonics. Some people like to use it. So we have, if I want to remember what sine is, I remember that it's the sine of an angle is opposite over hypotenuse, all right? Okay, sine is opposite over hypotenuse. Then if I want to remember what the definition of cosine is, right? Adjacent over hypotenuse, all right? Finally, what is the definition of tangent? Tangent is opposite over adjacent segment, all right? Tangent is opposite adjacent segment. So maybe you might remember this word. Maybe some of you are familiar with that. If you're not familiar with it, okay. I introduce you this kind of appealing, nice, forget. I think it's interesting. I like it. I like it. So hope you remember that. That's the way a lot of people remember how the definitions go, because it's really, really important. I want to emphasize in this. It's really important that you remember the definition, okay? And remember where you're standing. What's your point of reference? Because if I were to do the trigonometric ratios for angle B, they are going to be different. I mean, they're going to flip, okay? Because now A is going to be the adjacent and B is going to be the opposite, okay? But as long as you the ratios and how the definition goes, we do the whole math. Other than that, you just have to remember how to solve for a variable if needed. And we need to begin with tangent. And then we're going to go over a couple of exercises with sine and cosine, all right? So for those who want to take a look at the electronic version of the book, I'm going to be solving some of those exercises, okay? So I'm gonna start with, I'm going to go to page 542. I'm going to do exercise 1. Exercise 1. What is the question? We are asked to find what tangent of J and what tangent of K is. All right. And then I will, I will go over that by the end when we report the answer. It's also important how we're going to report the answer. Okay, so this is the triangle we are given with the corresponding measures. So this is K, this is L, here's our right angle, and this is J. And we are given some measures, 24 here, 32 here, and 40 right here. All right, probably as a matter of reference, I'm going to write tangent of an angle, whatever angle. I'm writing the letter alpha, Greek letter, all right? That is opposite over adjacent. Well, remember, I'm going to write so all right. But anyway, I like this one as well. Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Okay, so you keep this in mind as we solve this. And now we have to find tangent of J and tangent of K, these two angles, K and J. Okay, so it's just as simple as remembering, just keep in mind the definition. So tangent of J, so it means that I'm standing here, and tangent of an angle is opposite over adjacent. So the opposite is 24 and the adjacent is 32. I always like to write the definition like this before I plug in the value. So now I know that the opposite of J is 24 and the adjacent is 32. And if I simplify this is going to be 3/4. But for calculation purposes in the future, we like to report this like that, 0.75. And we're going to report 4 decimal places. And you will see why in the second exercise. Okay, well, no, maybe later on, but okay, for now, let's just make sure that we're going to report 4 decimal places. Okay, that's it. Now, that's all. Oh, sorry. Now, tangent of K. Let's go for it. Tangent of K. So remember, tangent. So it means that I have to do opposite over adjacent, but now I'm standing on K. So I am standing here. What is opposite to K? It's this segment. So it's 32. And what is adjacent? It's 24. So this is going to be 4/3 if we simplify, or this is also 1.3333. And that's it. Okay? Does that make sense? Hopefully, if you have questions, make sure you type them on the chat box, please. Okay. I haven't said hi to those who arrived a little bit later. Nice to have you here, guys. I'm glad to have you here. I really miss my classroom, but they are just so bored of being at home. They say they want to go back to school, but I say, well, we gotta be patient. So what else we can do, right? In the meantime, let's do some math, right? Well, now let's keep working. So now I'm going to solve another exercise from the book. Need to find the value of x, okay? And we are given this nice triangle here, like this. This is our right angle. Here's a 22. This is the x. We want to find its value, and we are given this angle right here, 61 degrees. And I want to clarify this. So important now. We use the degree category, type when we measure these angles, because in some calculator degrees, radians, not yet. All right. You're going to be using radians probably in SM3, but here we're going to be using degrees, so make sure that your calculators are on degree mode, okay? All right, so let's begin. So if we want to find the value of x and we are given this information, well, I'm going to use the trigonometric function in this case, we can use tangent because we have the angle and we have the opposite and the adjacent segments to it. So by this, we are going to say that the angle is 6, this angle is 22, and what is the adjacent segment is x, the one I don't know, okay? And we want to find out what that value is. So it means that I need to solve for x. And, well, just apply the old algebra you already know. It means that I need to make sure that I switch this whole thing, but be very careful. These two always go together. Don't split them. You cannot break them apart. They always go together, okay? So this is as if it were a number, yeah, like 5.2, 3.8, whatever. It's a number, so you cannot break them apart, okay? So I need to make sure that this x is completely solved for. So tangent of 61 equals 22, okay? Or if you want to say it as if I multiply by x on both sides, it means that this x right here multiplying was canceled with this x, and then we just have this x right here, okay? Keep that in mind. And now if I want to finish solving for x, what I have to do is I have to divide by tangent 61 on both sides, okay? With that, what happens is that this tangent and this tangent are canceled out. Oh, wait a minute, because you cannot see. I think you can now see, right? What is going on, right? So in the end, I will have x equals 22 divided by tangent of 61. And this is where what I just told you about the degree and radians is really relevant, okay? Because, you know, I tried it, and when I was solving this, I used the Google calculator and I typed this, 22 divided by tangent 61. And it seems like Google calculator is set on radians by default. So it gave me a crazy, well, not a crazy answer. And the point is that it wasn't crazy, so I almost fall for it. And I thought, okay, yeah, it's going to be 5 point something. But then I rechecked the exercise and it happened to be, well, different, okay? So I was wrong. And then I made sure that I did the right thing and set it up to degree mode. And when you do this, let me show you what you can do. You can try to find it in Google. Tangent of 61.8. So it's going to be 22 equals 1.8. And then when you do this division, you're going to have a 12.2, okay? And this is what we were looking for, okay? The length of x, okay? And probably if I wanted you to find what the length of the hypotenuse is, it's easy because you already have hypotenuse. And I would say, hey, can you find this angle? And you say, oh yeah, it's so simple because these two are supplementary angles. So this is going to be a 29. And then I have everything I want to know about the right triangle. By the way, that's what we mean with solving a right triangle. It means that you need to find the values, because if it is a right triangle, you immediately know that there is something you already know, that it's the right angle right here. So what are we missing? 2 or more angles, acute angles, and the 3 lengths of the segments, okay? But you know, I will go over that eventually because that's the next lesson. So for now, that's it about tangent, okay? Okay, I have a question that I'm going to answer by the end because this is absolutely relevant to a lot of stuff I did when I was taking some engineering courses when I was in college. So yeah, it definitely applies to a lot of stuff, Jessica, right? So yeah, let's say that I'm designing a kind of a machine and I want to give the proper numbers to that. So I am not going to build a very robust machine or a very weak machine. I will have to use a lot of trigonometry here, let's say something like that, and statics and machine design and other stuff. Anyway, there's a lot of applications to it, okay? Well, so now I'm going to go over sine and cosine, but you know now the basic idea, so you know that it's now, you know, for those who already got it, You are probably like, yeah, no, I'm bored now. I got it. I understand your frustration. But anyway, I'm going to do a couple of exercises using sine and cosine. All right, just so you get some. Now I'm going to go to page 548, and we're gonna do. Where are you? Oh, come on. This find sine of d, sine of f, cosine of right triangle. So the lengths here are 7, 25, f, and d. Okay, just so simple. Okay, so let's begin. Let's begin with sine of d. Sine of d. Remember, sine is opposite over adjacent over hypotenuse. Sorry, and d means that I have to be right. So 7 divided by hypotenuse is 25. All right, and that's it. All right, this is the fraction form of it. All right, or if you want to present it in the decimal form, you do 0.28, and remember 4 decimal places. Okay, just like that. So simple, right? Now we got the definition, so it's going to be pretty easy for you guys. So now let's do. Wait a minute. I need to see myself, so I'm okay. So now sine of f in here now. So the opposite is going to be this dE. So it's going to be 24 over hypotenuse is 25. Okay. So if you present this as in decimal form, it's 0.96 and 0 and 0. All right. That's it. And now we're going to go to cosine d and cosine f. And I want you to notice some interesting things here, okay? We're going to do cosine of d, which I remember is adjacent divided by hypotenuse, all right? And adjacent to d, so this is d, and the adjacent is this 24. And I want you to notice something, and then hypotenuse is 25. Can you see something? We have angles F and angles D. Angles F and D. All right. We just calculated sine of F. It's the opposite of it divided by the hypotenuse. It was 24 over 25. Look at this. Right. So it's like they have some kind of connection. The sine of one angle is the same cosine of the other angle. Okay. And when you get to this part, you will know that sine of d is going to be equal to the cosine of f. Interesting things, okay? So, I'm not going to write the decimal. I have no more space in here, but now you get it. It's 0.96. So cosine of f is going to be adjacent to f, and the hypotenuse of the triangle, the adjacent of f is 7 over 25, and then again, I don't have enough space, but it's going to be this but swapped. Okay, that's it. Good. Yeah, good job, Omar. Okay, now well, seems like I don't know, you have questions? He's got some time available for you guys if you want to discuss with him, get his help. We are more than happy to help you guys. Honestly, I'm a little bit bored, right? Because I don't have you with me. Yeah, so I prepare things. I'm checking that you with us and doing activities here and there. I don't know. I'm going to be sending my advisory students an email today with a survey and see how they're doing, right? But yeah, I mean, I think that's what I usually do with you guys. I explain the basic concepts with some application exercises, and then it's time for you to work on your quiz, on your activities. Okay, so Tom asks, Will chapter 10 be released by the time we return to school? All right. You're making a very interesting question, okay? Because it is, oh yeah, so we have the optimistic and the realistic. Interesting. Yeah, I like that because Jessica is answering, hey, we probably won't go back, to be honest. Haha, yeah, I'm laughing a little bit as well because, well, we've been told so far, from the news and everything, even though, well, anyway, means that we get to the point, when we get to the point of, as I have in my schedule, the date of when I would be doing the test, we will have the test, right? We will have chapter 9 test. You will take it through Canvas. You already know how tests work because you've done it before. And yeah, I feel you, Jessica, but it's time to be creative because I'm enjoying my time with soccer. She wanted to start playing soccer, and I am being her personal coach. So, and the other one is practice. We're doing, and I have to think about a lot of stuff, but I've been able to read a lot. I love reading, so now I have a bunch of. Yeah, Steve, that's right. Probably you might want to read a little bit about how people did in the past with other, other situations like this, the quarantines and everything. By the way, they say, I don't know if this is accurate or not, but Sir Isaac Newton in a town close to where he was standing. I guess that he was part of the Cambridge University, and then because of the middle of it, days are really long, but whatever. Gotta do something. I have a bunch of books anyway. So, okay, guys. So, oh, great question, Tom. Okay, let's do an exercise about that because this concept is necessary. All right. I don't know if this is part. I haven't checked 9.6. Probably you're asking that question from a 9.6 perspective. Yeah, you are making a question from 9.6, which I'm going to be doing. Today is what? I don't know what day is today. Wednesday, right? Yeah, okay, yeah. You lost track of time. So, yeah, I'm going to be explaining that inverse tangent, inverse sine, inverse cosine on Friday. All right, that's going to be 9.6 lesson. That's going to be 9.6 video. All right. Yeah, the way that we reverse it, it's a little bit different than when we you're moving ahead, right?
Can I say something real quick?
Yeah, sure.
Make sure you learn sine, cosine, and tangent really well, just the normal way, what we're doing right now. If you learn it really, really well,
division, okay, of the two segments. So that's also really important stuff to take into account. Okay. Thanks, Steve, for that. Okay, guys. So I'm guessing that if we don't have any question regarding any of those exercises or about the topic that we just discussed, so email, we can kind of even make arrangements if necessary to do some individual Zoom meeting if necessary. So I honestly don't have any something like that because I am kind of mixing my time, and then sometimes I do in the okay for me, okay, but it's just my case. I don't want to have you contact Steve at 1 a.m. Saturday because you were bored like Jessica and you said I'm going to text or email Steve and see if he's available. Probably you might find me over there, but it's because I want to do that. Okay, all right, guys, so I guess that's all for now. Thanks for coming. Please let others know that we have this video on YouTube in case that for those who didn't make it or for those who made it a little bit later. Friday, probably by this time, 11:30, and we're going to be discussing lesson 9.6, okay? So I'm going to keep this meeting open for 1 or 2 more minutes, and in case anyone wants to make a question about anything. Let's say something about the trigonometric theorem in Canvas. It doesn't say like trigonometric theorem, Jessica. What we did is 9.1 was the Pythagorean theorem. Probably, maybe is that what you were asking? I don't know. Pythagorean theorem, that was 9.1. Then 9.2 was a special right triangle.